In my previous video, I covered solutions to the first three problems. And so in this video, I want to cover the last three. So we'll start with number 4. Monday's closing value of your company's stock was up 3/2. Tuesday was up 1/2. Wednesday's was down 1/4, but Thursday's closing was back up again by 3/2. Finally, the stock closed the week down 1/16. What was the net change for the week? All right, so now let's sort of unpack this problem a little bit. Reading it again, we know the stock was up on Monday, up on Tuesday, down on Wednesday, up on Thursday, and it doesn't say the word Friday, but closing the week, the implication there is that on Friday it was down 1/16. Now, what was the net change for the week? So this word net means total. Overall total. Overall total. So what is after those 5 changes happen, what was the overall total change once you take into account all 5 individual days? So going back through the problem, on Monday, the stock was up 3/2. Up means increase, or if we're going to, again, translate, with any word problem, we have to translate the words from English into a mathematical, either an expression or an equation using numbers, letters, and mathematical symbols. So this idea of up, meaning increase, well, that's addition. So up 3/2 on Monday. And again, Tuesday was up, so that's more addition, up 1/2. Wednesday was down 1/4, so that's subtraction. Thursday was up again by 3/2. Finally, closed the week on Friday down 1/16. So we have 3 additions and 2 subtractions. So if we go through the problem, Monday, Tuesday, Wednesday, Thursday, Friday, we're starting with positive 3/2, up 3/2 on Monday, and then up again on Tuesday, so that's plus 1/2. Down on Wednesday, so that's a minus 1/4. Thursday was up, so that's a plus 3/2. And finally down on Friday, so that's a minus 1/16. Now, the only way that we could add or subtract fractions is if they have a common denominator. And so we need the common denominator, and the common denominator is the least common multiple of the denominators, or the smallest number that all of the denominators evenly go into. And in that case, 16 looks like it would be the common denominator. The reason 16 is the common denominator is because 2 goes into 16 8 times, 4 goes into 16 4 times, and 16 goes into 16 1 time. So all of these denominators, the 2's, the 4's, and the 16's, they all divide evenly into 16. So 16 is the least common denominator. So all those denominators, before we do any addition or subtraction, all those denominators have to be 16. So this first one, 3/2, well, how do you make a 2 into a 16? Well, you multiply it by 8. But we're not allowed to just multiply half of a fraction by 8. We're only allowed to multiply by the number 1. And so we'll multiply by the number 1 in the form of 8/8. Because if we multiply by 1, we don't change the number. We don't change the value or the meaning. So the only way we could do that, and incorporating an 8, would be 8/8, since 8/8 is equal to 1. And so top times top, bottom times bottom. We're using 8 because we need an 8 on the bottom. 8 times 2 is the 16 that we need. And so whatever you do to the bottom, you got to do to the top. So 8 times 3 on top will give you 24. Next fraction, over 2. So that 2 needs to be a 16, so we'll hit it with another 8. 8/8. So top times top, 8 times 1 will be 8. The next fraction, we need to increase that, or we need to change that 4 to a 16. So 4 times 4. So we'll multiply by 4 over 4. And top times top, 4 times 1 is 4. We have another 2. So again, we'll use an 8 over 8. And so top times top, 8 times 3 is another 24. And then the last one, it's already the 16 that we need, so we'll just leave it 1 over 16. And so now that we have the common denominator of 16, we could simply go across the top. We have a 24 plus an 8 minus a 4 plus a 24 minus a 1. And so our final fraction will be 16. And if we pop this into a calculator, 24 plus 8 minus 4 plus 24 minus 1 will give us a grand total of 51 on top. So our total overall answer would be 51 over 16. All right, number 5. The ocean surface is at 0 feet elevation. A diver is underwater at an elevation of negative 169 feet. Okay, so in this case, negative means below the surface of the water or down. Positive means above the surface of the water or up. So a diver is underwater at an elevation of negative 169 near a rock formation. In this area, the ocean floor has an elevation of negative 390. That means the ocean floor is 390 feet down or below sea level, below the surface of the water. The rock formation rises to a peak of 239 above the ocean floor. So it's 390 down to the ocean floor, and then from the ocean floor, the rock is going up 239. How many feet below the top of the rock formation is the diver? Okay, I think this is a little bit complicated to understand. And for me, as I've mentioned in my last video, I'm a very visual learner. I like pictures, diagrams, labeling. So whenever possible, and this is advice that I'll give for any word problem you do, if there's any time, a situation where you can draw a diagram or draw a sketch to represent the problem, do so. It often has a way of simplifying what you actually have to do. And your diagram should be as simple as possible. I mean, a diver is a person underwater. You don't have to draw a little person or a little stick figure. So let's do something like this. We have the ocean floor, and then we have the surface of the water. And in the problem, we're told that the ocean surface is considered 0. And so underwater is negative. And it says the ocean floor has an elevation of negative 390 feet, or 390 feet down. We're also told that there's a diver, and that diver is at an elevation of negative 169. So the diver is down 169 feet. But that's not the elevation. The elevation is, well, that's not the distance from the ocean floor. That's the distance from the surface. So the diver is down 169. And now the rock formation is up from the ocean floor 239 feet. The question is, how many feet below the top of the rock formation is the diver? So how far apart vertically is that green dot and that red dot? The red dot is below the green dot, or the red dot is the diver. The green dot is the top of the rock. Okay, so our question is, what is this distance. How far apart are those two? Now the problem is that 169 and the 239, they're coming from different directions. So what we need to do is sort of put them both in the same frame of reference. So if I said, let's simplify this. If I said, for example, myself and a friend of mine are both in a swimming pool and we're both underwater, and I am 6 feet down and my friend is 9 feet down. How far apart are we? Well, if I'm 6 down, he's 9 down. Well, he's 3 more feet than I am, so we're 3 feet apart. But in this example, we're both, coming down from the top. So let's say, how far down is the top of the rock? So what is this? What is this distance? How far down is the top of the rock? That way we can put it in the same context as this. So let's see, if the whole distance from surface to the bottom, that's 390, and the rock accounts for 239 of that, then the distance from the rock to the surface is the rest. The 390, take away the 239. So 390 minus 239, well, that's a difference of 51 feet. Or sorry, 151 feet. 151 feet. So saying 239 up from the bottom is the same as saying 151 from the top. So we could label that 151 feet. So now it's similar to this. If the diver is down 169 and the rock is down 151, how far apart are they? Let's put a negative sign here to say down 151. And so now the difference, so let me erase this for now. The difference between being down, just like what's the difference between being down 9 feet and being down 6 feet? Well, the difference is the 3. Well, what's the difference between being down 169 and down 151? The difference between those two numbers is 18 feet. So the distance between the diver and the top of the rock looks like, in this case, 18 feet. Now, I'm not saying drawing a diagram made this an easy problem. It didn't. But drawing a diagram, in my opinion at least, made this an easier problem. It at least helped to simplify a little bit what's going on in the problem. All right, that's number 5. Now let's move on to number 6. The two charts, and by two charts, I'm talking about the chart for Abe, Bob, and Carl, and then the chart for Don, Ed, and Frank. A, B, C, D, E, F. How original. These two charts show the weight gain of some people and the weight loss of other people. So the chart on the left, they gained weight, so those numbers are positive, and the chart on the right, they lost weight, so those those values are negative. Use the information to answer the question. What is the difference between the weight gain of Bob and the weight loss of Don? Now, in solving word problems, very often it comes down to identifying key words. Before we do the math, we have to first determine what math we have to actually do. Before we do the calculations, we need to figure out what to do, what operations to apply. Do we add, subtract, multiply, divide, or something else? And in this case, the key word is difference. And difference means subtract. The difference between two things is the distance between them, or how far apart they are, and mathematically, difference means subtract. So we're basically taking Bob, and we're taking Don, and we're subtracting the two. So we don't need Abe, we don't need Carl, we don't need Ed, we don't need Frank. we're just looking at, let's switch back to green. We're just taking Bob's weight gain, and we're looking at Don's weight loss, and we're subtracting those two. So Bob is 4,208. Don is a negative 2,958. All right, and if we're subtracting a negative, two negatives make a positive, so that's the same as saying 4,208 plus the minus makes a plus, 2,958. And when we add these two numbers, which I've already done in a calculator, we get 7,166 grams. I know it's grams because the chart is labeled in grams. Okay, and that's our final answer, and that does it for this problem. I hope this was helpful.